Right, this is a video for lesson 4.3 on exponential functions, and so I should have an S on that. So this is going to be just the page 1, and we start with the warm-up. So if you go and work these 3 problems, and then go ahead and take a look at problem 7 and see if you can fill out the rest of that table. So I recommend pause, work the problems, and then unpause to review. All right, so for this first problem here, this is 2 to the 5th power. So just a reminder, when we have that, that is an exponent, meaning we are doing repeated multiplication of 2. So 2 times 2 is 4, times another 2 becomes 8, times another 2 becomes 16, times another 2 becomes 32. So in other words, if I multiply all 5 2's, this is what I get. All right, for your next one, this is going to be negative 3 to the 4th power. Once again, that is repeated multiplication of the base. So you really have 4 negative 3's being multiplied. And we'll just go and start left to right. Negative 3 times negative 3 gives us a 9. And then we still have the rest of this here. 9 times negative 3 gives us a negative 27. And we still have another negative 3 being multiplied. And negative 27 times negative 3 is going to give you a positive 81. Right, for our next problem here, this will be 5 times, and 2 to the 3rd is 3 2's being multiplied together. When I multiply all of these, 2 times 2 is 4, times another 2, that's going to be 8. So it's really just going to be 5 times 8, which is 40. Going on to our next one, here we're going to do 3 times negative 5 to the 3rd power. So once again, that means we have 3 negative 5's being multiplied together. Now, in this case, I don't necessarily have to start with multiplying by the negative 5's. I could just start going left to right, but I'm going to go ahead and multiply these together. So if you can do this on your calculator, right? Negative 5 times negative 5 times negative 5, it'll give you a negative 125. And then the 3 times the negative 125 is negative 375. For these problems here, we're going to go ahead and once again, we have an exponent of 3. That means we have 1/2 3 times. So that's 6 times 1/2 times 1/2 times another 1/2. When we multiply fractions, we multiply the tops. So 1 times 1 times 1 is going to be 1. And then 2 times 2 times 2 is going to be 8. So when we multiply all of those together, we multiply tops, right? So the 16 multiplies to the top. 16 times 1 is 16 over 8, and that'll give us a 2. Okay. And then for our last one, negative 2/3 to the 3rd power is negative 2/3 times negative 2/3 times negative 2/3. And once again, when we multiply fractions, we multiply all the tops. 2 times 2 times 2 is going to be 8. And 3 times 3 times 3 is going to be 27. Now the question is our answer positive or negative? So when you have 3 negatives, 2 will cancel, and you'll have a negative left over. All right, now let's go ahead and take a look at our last problem here, where we're going to take a look at the table. Okay, so looking at this last problem here, we're looking for a pattern. And if we look here, this goes from 2 to 4 to 8. So this is really doubling. 2 times 2 is 4. 4 times 2 is 8. So we have this doubling pattern going this way, which means if we go the opposite direction, this should cut in half. Half of 2 is 1. Half of 1 is 1/2. Half of a half is 1/4, and half of a fourth is 1/8. So these are the actual values for that. I'm going to show you that that's true, because we're looking at this equation y equals 2 to the x. So we're talking about what does an exponent mean if the exponent is 0 or if the exponent is negative. So we can show that like 2 to the 3rd is 8, and 2 squared is 4, and 2 to the first is 2. 2 to the 0 is 1. And a lot of people want to say 0 on that, but that's not actually true. And 1/2. Okay, so the big takeaway from this then is when you see negative exponents, it actually means the opposite of positive exponents. So like if I had 2 to the 3rd power, that means to multiply 2 that many times. So 2 to the negative 3rd power means the opposite. You're actually dividing by 2 that many times. And so all these 2's are now in the denominator because they're being divided, right? You're dividing by 2 that many times. That's where you get that 1/8. Now, a lot of times in your calculator, they might give you decimal values as well instead of the fraction value, but that's really what's happening there. And that's a kind of important conversation because as we get into the lesson, you're going to see the same type of thing happen. So let's take a look at this problem here. We're going to start with what we call an exponential function. And so an exponential function, you have a and a b, and the value here for a is going to be your start value, so very similar to what we saw with the linear equations. And b is going to be either growth, a growth factor, oops, I can spell, growth factor, or a decay factor. And it really depends on the value of b. So if b is greater than 0, it's bigger, or sorry, is this wrong? This is supposed to be 1. I have a mistake in my notes. We need to fix that. If it's greater than 1, it's going to be growth, and if it's less than 1, it's going to be decay. And so for this equation here, when we look at this, this is your a and this is your b. So this is going to be your start value. It's going to be your start value. And then this is going to be your growth factor. And since it's greater than 1, it is going to be growth. All right. So we really can use our calculator to generate the values on our graph, so we don't have to necessarily do all this by hand. So as we plug these values in, we'll go 3, parenthesis, 2, and then I'm going to raise it to a power using this caret key right above the x squared. And I'm actually going to start at the bottom of the table. I'm going to put 3 in. When I do that, I get 24, so that's what I'm going to put in here. Now, for this one, I am going to do this by hand so you can see what's happening. So when I say f of 3, I'm really doing 3 times 2 to the 3rd power. And so this is 3 times 2, 2, and 2. So 3 2's being multiplied. When you multiply all of these together, that's what gives you your 24. All right. So we're going to do the same thing for these ones here. So to finish the rest of these, I'm just going to go ahead and use the calculator. So we'll go up to that equation. I'm going to copy it, and then I'm just going to replace the 3 with a 2, and so that'll be 12. All right, and then we'll go ahead and copy it again. We'll change that to a 1, and that's going to be a 6. And then I'm going to change that to a 0. And that's going to be a 3. Right, so we're just plugging those in. Now you may start to see the pattern. These are cutting in half, right? As you go down, they're doubling. 3 times 2 is 6. 6 times 2 is 12. 12 times 2 is 24. So if you go down, you should be dividing. So this becomes 1.5. This becomes 0.75. And then this becomes half of that, which is... Sorry about that. So I'm going to put the 0.75 and divide that by 2, and I get 0.375. So that winds up being that value. Now, I could have once again done this by plugging in the 3, put the 2 in, and as an exponent, put in the -3. I get it gives me a fraction, right? I change that fraction to a decimal, it is the same value. So once again, you can put these values in, but you can also look for the pattern of the table. So you can use the equation to get them or the pattern. The last part is we have to graph this. So I'm going to draw a line for the y-axis. I'm going to draw a line across for the x-axis. And I don't really need values underneath because none of these are negative, right? So to graph this, I'm going to put our -3, -2, and -1 for this side, and then 1, 2, and 3 for this side for our x values. This, of course, is 0. And I'm going to have to decide on a scale because we have values like 1.5 and 0.75, right? Really small values. And then we have large values like 24. So I think on this one I'm actually going to go by 2s. So I'm going to go 2, 4, and I think this will fit. Now, the reality with these type of graphs with exponentials, some points you'll be able to graph nicely, and other ones there's just no way, no nice way to graph all of them. So you want to make sure that you just do the best you can when dealing with those problems. 22, 24, that should be everything. So 0, 3 is my first point. So 0 and then 3 should be in between 2 and 4. Then I have 1, 6, which is this point here. I have 2, 12, 2 and 12, and then I have 3 and 24. So I'm going to go ahead and draw this, and it curves upwards, kind of goes through there, and then continues off the graph, so it has a sharp curve. Now the ones over here, I have 1.5, which is going to be, well, that's 1, so 1.5 is here. 0.75 is going to be about here, and this value is down here. So I'm going to go ahead and draw that. Oh, that's not very good. I'm going to draw that as low as I can, and this just keeps getting smaller and smaller and approaches 0, but never actually becomes 0. And that's what your graph looks like. Please continue on to page 2 for this video.